Imagine the thunderous roar of 4 massive turbofan engines igniting, propelling a sleek 146-foot-long behemoth into the sky at speeds exceeding 900 miles per hour. This is the U.S. Air Force B-1B Lancer, a supersonic variable sweep wing bomber that's not just a flying fortress, but a pinnacle of aerospace engineering. Nicknamed the Bone from its B-1 designation, this aircraft blends raw power, advanced stealth, and unmatched payload capacity into a machine that's as technically impressive as it is operationally dominant. Designed during the Cold War to penetrate Soviet defenses, the B-1B has evolved into a versatile global strike platform. Let's geek out on its technical specs, exploring the engineering marvels that make it tick, while weaving in its thrilling history and combat prowess. The B-1B's origins trace back to the 1960s, when the Air Force sought a replacement for the aging B-52. Rockwell International, now Boeing, developed the initial B-1A prototypes, which first flew in 1974. These featured variable sweep wings capable of adjusting from 15 degrees for low-speed handling to 67.5 degrees for high-speed dashes, allowing Mach 2+ capabilities. However, President Carter canceled the program in 1977 due to costs and emerging missile tech. Revived by Reagan in 1981, the redesigned B-1B sacrificed some speed for stealth and durability. Production ran from 1984 to 1988, yielding 100 aircraft at a unit cost of about $283 million in 1998 dollars, each built with a titanium and aluminum airframe weighing 192,000 pounds empty. At the heart of the B-1B's performance are its 4 General Electric F101GE-102 afterburning turbofan engines. Each engine produces 17,390 pounds of dry thrust and surges to 30,780 pounds with afterburners engaged, for a total thrust-to-weight ratio of around 0.38 at combat weight. These low bypass engines, bypass ratio of 2:1, feature a 3-stage fan, 9-stage high-pressure compressor, and a 2-stage turbine, optimized for efficiency at subsonic speeds and raw power for supersonic bursts. The afterburners create iconic diamond-shaped shockwaves in the exhaust, a visual hallmark of the Bone's might. Fuel capacity is massive, 265,274 pounds internally across 10 tanks, enabling an unrefueled range of over 7,455 miles at 30,000 feet, or about 12 hours of flight time. With aerial refueling, it's virtually unlimited, as demonstrated in 30-plus-hour missions. The airframe's variable geometry is a technical standout. The wings span 137 feet fully extended, 15-degree sweep for takeoff and landing, optimizing lift with a wing area of 1,950 square feet and an aspect ratio of 9.6. At full 67.5-degree sweep, the span shrinks to 79 feet, reducing drag for high-speed flight. This is controlled by hydraulic actuators with redundant systems for reliability. The blended wing body design incorporates chined edges and serpentine air intakes to minimize radar cross-section, RCS, estimated at 1 square meter, about 1/100th of the B-52's. Radar-absorbing materials, ram coat critical surfaces, and the engine inlets are S-shaped to hide compressor blades from radar waves. The maximum speed is Mach 1.25, about 950 miles per hour, at sea level, or Mach 0.92 at low altitude for terrain-following penetration, thanks to the Terrain-Following Radar TFR system. Structurally, the B-1B is built tough. Its fuselage is 146 feet long with a 13.7-foot diameter, housing a crew of 4: pilot, co-pilot, offensive systems officer, OSO, and defensive systems officer, DSO. The cockpit features ejection seats with 0-0 capability, eject at 0 speed/altitude, and a pressurized cabin for high-altitude ops up to 50,000 feet service ceiling. The airframe uses 42% aluminum, 22% titanium, 19% steel, and 17% composites, with a maximum takeoff weight of 477,000 pounds. Load factors range from plus 3.5 G to minus 2 G, allowing aggressive maneuvers despite its size. The landing gear is tricycle type with 4 main wheels per bogie, retracting into the fuselage for a clean aerodynamic profile. Payload is where the B-1B shines technically. It boasts the largest internal bomb bay in the USAF, 3 compartments totaling 75,000 pounds capacity, with dimensions allowing for massive munitions. The forward bay is 15 feet long, mid 22 feet, aft 15 feet, all 7.5 feet wide and high. It can carry up to 84 Mk 82 500-pound bombs, 30 CBU 87/89/97 cluster bombs, or 24 JDAM GPS guided munitions. For standoff strikes, it integrates 24 AGM-158 JASSM cruise missiles, range 500+ miles, or 12 AGM-158 CLRASM anti-ship missiles. External hardpoints add another 59,000 pounds, though rarely used to preserve stealth. The Sniper Advanced Targeting Pod provides laser designation and infrared imaging for precision strikes, with a resolution of 1024 by 1024 pixels and 360-degree field of regard. Avionics are cutting edge. The Offensive Avionics System, OAS, includes the AN/APQ-164 multimode radar, a phased array unit with synthetic aperture mapping for ground targets at 100+ miles range. It supports terrain avoidance at 200 feet altitude while flying at 600 knots. The Defensive Avionics System, DAS, features the AN/ALQ-161A jammer, covering 0.5 to 20 GHz frequencies with 36 antennas for electronic countermeasures. Upgrades like the Integrated Battle Station, IBS, in the 2000s added color multifunction displays, improved data links, Link 16, and software for new weapons. The flight control system is quadruple redundant fly-by-wire, with stability augmentation to handle the variable sweep's center of gravity shifts. In combat, these specs translate to dominance. Debuting in Operation Desert Fox, 1998, B-1Bs dropped 20% of the ordnance despite flying 2% of sorties. In Afghanistan, 2001, they set records with 24 JDAMS per sortie, achieving sub-10-meter accuracy via GPS/INS guidance. Low-level flight at Mach 0.85 hugs terrain to evade SAMS, with the automatic terrain following system maintaining 200-foot clearance, using radar altimeters and inertial navigation. Fuel efficiency is 0.57 pounds per nautical mile at cruise, better than the B-52's 0.74. Recent integrations include hypersonic weapons testing, like the AGM-158 ARRW, expanding its role against peer adversaries. Challenges have tested its engineering. Early fleet groundings in the 1990s due to engine compressor failures led to redesigns. Structural fatigue from low-altitude ops necessitated wing pivot reinforcements in the 2000s. Maintenance is intensive, 119 hours per flight hour, with cannibalization rates once hitting 20%. Yet, upgrades keep it relevant. The Sustainment Block 16, SB16, added fully integrated data links and anti-jam GPS. Fun technical tidbits. The B-1B holds 62 world records, including sustained Mach 0.92, flight with 40,000-pound payload over 1,000 kilometers. Its afterburner fuel flow is 360 gallons per minute per engine, guzzling like a fire hose. The radar can detect ships at 200 miles, and the bomb bays open in under 2 seconds for rapid release. Crews endure up to 9 G-turns, with G-suits inflating to prevent blackouts. As the B-21 Raider looms for retirement by the 2030s, the B-1B's technical legacy endures. With over 10,000 flight hours per airframe on average, it's a testament to robust design. From its variable wings to stealthy contours, the bone embodies engineering excellence, a supersonic symphony of power and precision that continues to captivate aviation enthusiasts and deter foes alike.